Hi everyone. Good morning for those early birds joining from this side of the world. Good afternoon, good evening, depending on where you are. Thank you so much for joining this demo day. I'm very excited to start this session and to be here with you today. My name is Noemi. I'm part of Omdena's marketing team. And today we will be talking about the processes and tools allowing companies to build value creating and innovative solutions. So let me share my screen to start. Okay. So oops. Okay, so thanks for being here today. So without any doubt, artificial intelligence has taken the world by storm. In the previous years, a significant rise on the adoption of AI was seen all around the world in various industries, including NGOs and social enterprises. And this is a topic which we discussed during our last demo day 2 weeks ago. And the recording is available on omdena.com if you'd like to deep into this topic a bit further. So AI can amplify human capabilities and turn exponentially growing data into insights, actions, value, helping organizations develop innovative customer experiences and a new competitive edge. So AI and machine learning are not always the answer to everything, but used properly, these technologies have the potential to significantly boost and broaden the impact of companies. So the big question is, how do organizations implement machine learning, deep learning, artificial intelligence to their core technology? How to succeed in that? So today, we'll be talking about the tools and processes allowing organizations to become AI enabled. A look behind the scene revealed that in order to successfully develop and scale AI solutions, it is much easier with the right technologies and the right tool partners. So this is why we brought together YCombinator backed successful startups and established Omdena partners to share their insights with you. So we're very excited to have you with our 3 guests today to dive into this topic. And for the sake of the logistics of this webinar, I'll start by sharing a bit more about Omdena, who we are, what we do, how we do our work. And then we will leave some time for each of these 3 panelists from Labelbox, Spell, and Activeloop to present their technology, and they will give an overview of how it can be used in real-world examples. And at the end, we will have some time for a panel discussion. So please feel free to ask questions in the chat at any time, and we'll answer those at the end. And please let us know if the questions are directed to a particular speaker or if it's more of a general questions. And I would like to point out that this session is being recorded and will be shared on omdena.com and on social media. Omdena. Omdena is a collaborative platform that was built to build innovative, ethical, and efficient artificial intelligence solutions to solve real-world problems. Our platform allows AI and domain experts from all around the world to collaborate on projects that matter to them. In the 15, 16 months since we've launched, We have worked on about 30 projects across many sectors with partners that include UN agencies, many NGOs, startups, foundations, and we have addressed many significant issues related to hunger, sexual harassment, land conflict, gang violence, or even wildfire prevention. And through this process, we have brought together more than 1,300 people, experts in AI, data science, machine learning, but also domain experts, and to work in groups of 50 to 60 on our intensive 8-week projects. And within our framework, these teams work on a bottom-up fashion, meaning that they are self-directing the development of the project. And over again, we can see the strong impact of bringing people together who have different experiences in their professions, in their interests, in their lives. And our teams are typically 30% female. At least 15 countries are represented on every project, and people are working from all over the world. So this diversity, together with our bottom-up approach, really fosters innovation, creativity, and leads to trusted and ethical results. So today, our focus today is to hear from 3 of our tool partners who've worked with us on some amazing challenges, and they'll be sharing their technology, how it works, and provide real-life example on how to put it to use. So please, as always, if you have questions directed to one of the panelists, please write them in the chat, and we'll get to it later. So now the exciting part starts. Without any further ado, let me introduce you to our first speaker, Brian, founder and CEO of Labelbox. So Brian is an accomplished aerospace engineer, data scientist, and software developer turned serial entrepreneur. He is currently co-founder and president of Labelbox, the industry-leading training data software that is accelerating global access to artificial intelligence. He began his career doing aerodynamics, testing and flight certification for the Boeing 787 Dreamliner. Afterwards, he built an aerospace company that put hardware on the International Space Station and is recognized by Forbes 30 Under 30 for transforming enterprise technology with machine intelligence. So we are delighted to have him here today to present Labelbox. So please now you can share your screen and start presenting.
Thank you, Naomi. That was great. Hey everybody, Brian here. So let's get started. Okay, so as Naomi mentioned, Brian, president and co-founder at Labelbox. Today we'll be talking a little bit about how Labelbox enables organizations to get to production machine learning faster. And we'll talk a little bit about our partnership with Amdena as well. So we've all read the projections, we've all seen the news, and we've all understood the wave of AI, and it's supposed to be transforming our businesses. It's supposed to be solving humanity's hardest problems. And we see that opportunity amongst ourselves and our teams. But the question is, why is it taking so long to maximize this impact? The data on machine learning development is pretty stunning right now. Almost every company encounters delays getting their machine learning systems to production. And more than 3/4 of projects are stalling along the way. So these are really stunning stats, and there's a lot of intricacies and things that cause this. What we found is that data labeling and data management is at the heart of this problem. And what we've done at Labelbox is built a training data platform that's designed specifically to train machine learning models faster. When we think about the challenges of training data development, they come in the form of three sort of categories. There is managing the data and the people and the process and the iteration itself. There is the annotation of the data, so that's labeling and those things that we're familiar with. And then there is the iteration loop. Every piece of technology and capability is developed through a learn, do loop, an iteration cycle. We're very familiar with this in software or anything else that we do, even developing aerospace technology or what have you. And we know that in machine learning, iteration is super slow. It can take typically 2 to 4 weeks to do an iteration in a machine learning environment, which is quite shocking compared to the iteration cycle in software, where it's just measured in a matter of hours. So in a training data platform, we need all three of these to come together to get at the heart of the problem. And when we take a step back and look at how a training data platform works together to solve the training data development problem, it looks like this. As you can see, annotation is at the heart of it, right? We're labeling data. We're essentially programming the machine learning system directly through labeling and the quality tooling that's being used. On the left, we're managing. So we're saying who's working on these projects, who's labeling the data, what is the quality, what are the workflows that we're orchestrating and administrating as a group, as a data science team, as a labeling operations team. And then that all powers an iteration loop so that we're searching, browsing, and curating training data. We're understanding what the model needs and how we're going to iterate through our data to drive model outcomes. And what's important about a training data platform in particular is that on the left, you can see we have different ways of generating labels, different methods and different inputs to the data development system that are all essential. What we found working with over 200 leading AI teams and dozens of leading academic institutions is that there really isn't a silver bullet in developing machine learning. You need all the different tools in your tool belt to get things done and to get performant machine learning models into production. So you do need typically external labeling services or some sort of outsourced team in many cases. You very often always need an internal team of labelers, data scientists, data engineers, and so on. And then as we mature as an industry, we're beginning to be able to take advantage of machine labels, programmatic labels, weak supervision, those sorts of things. I'll talk a little bit about that. But all of these different techniques and labeling methods are very essential for developing machine learning reliably. So touching quickly on each of the sections of the training data platform, I mentioned the manage layer. This is your centralized place to store, explore, reuse, and export training data. It enables the collaboration across teams, similar to what you would find in GitHub, and then it allows you to orchestrate those workflows in a similar way that you would see in a software development environment or what have you, where you have maybe multiple steps, you have reviewing, you have different levels of access to different data and different tasks being performed on those access levels. So it's all here in one place, and that's really important in the development of data, so you're sharing a context. Then we move to annotation. Of course, the heart of data labeling is the annotation process itself, and a training data platform typically provides world-class tooling here and then allows extensible work on top, so you can build custom labeling tools and really leverage all the automation that's available. Finally, iterate. Iterate is the heart of any technology and capability development. So iteration is absolutely essential. In Labelbox, there's a lot of things that are providing the iteration loop and facilitating it that we can't get into today, but suffice to say that this is a huge focus of how modern teams are building AI. And I wanted to touch a little bit on one of our newest technologies called model-assisted labeling. And what it allows essentially is the ability to use your machine learning models to assist in your labeling process. And as you can see here, there's a model on the left. it's providing through an integration predictions on the data in Labelbox itself through a very clean integration into the Labelbox platform where all of your data is residing and where you're managing it. Those labels get put into the data, and then the team can be assisted in the labeling process. And then which things are labeled and which things are corrected are submitted back into the model for additional model training. So this can save typically between 50 to 70% of labeling cost and increase productivity and drive accuracy. So a new technology from Labelbox that's seeing extraordinary performance in the industry today. And the reason that is because, as we know, labeling scales linearly, right? And labeling cost with model performance is this logarithmic curve. And so if you use some basic editor-assisted labeling function, then you're just going to get some sort of static improvement in your cost per annotation and cost per model performance. But really, what you want is to use your own model, because your own model will keep improving. You can go through iterations of improvement. And ultimately, the pursuit and the end state is that you have the ability to kind of unbend that model performance and labeling cost curve. That's what really enables you to drive into the very high accuracy levels for production machine learning, because you need to achieve very high accuracy, and the amount of data to label at that scale of data set size is quite significant. And so you want to work as hard as you can to unbend that model performance cost curve. And model assisted labeling is now appearing to be kind of the industry, the superior industry technique to do that. So that's something we support now in Labelbox. Wanted to share that as one of our newest technologies. All right. Now talking about how Labelbox supports Omdana, it's been an incredible year and a half-ish working with the team, and we're so proud to support them in solving some of humanity's toughest challenges. Just a quick look at our partnership with Omdana. There's about 100 participants on Labelbox through the Omdana account. They've done 1,000 hours of labeling. They've labeled tens of thousands of images. They have over 30 projects in work, past, current, and future. And we've been working together for the better part of 2 years now. So really exciting, and something we're very proud of at Labelbox. A couple of projects that we've touched and helped Omdana on. One is a tree detection analysis. So this was really cool because obviously in California, where I grew up, forest fires are a really big deal, and it's a big deal in Brazil and other areas as well. And so they developed a machine learning system that reached 95% accuracy on some very modest specs here in a very standard model architecture, and very quickly within the 2-month challenge. So through this ability to detect trees, they're able to identify hotspots where fires can occur and ultimately save lives. So a really cool project that we supported some time ago. And then today, an ongoing project that we support is preventing malaria infections. And this is using topography and satellite image analysis to identify areas and pools of water where malaria can be. And of course, you have to treat these pools of water. So how do you know which pools have been treated and all of that? You must use satellite imagery and topography understanding to keep a track of that and to make sure you're getting all the different pools of water. So this is currently an ongoing project from my understanding, and there's a 50-person team working on this. So we're very proud to support that. I think Leonardo had an amazing quote in one of his articles talking about his work on the tree detection. People make all the difference, and there's no walking alone challenge that can replace that. So I love that, and I think the people of Omdana really show that with their work and how they affect others. So thank you to the Omdana community, and thanks to everybody here.
Thank you. Thank you so much for this great presentation. We will get to questions after, but now I will be introducing our second speaker. The company will be Spell. So Spell is a powerful platform for building and managing machine learning projects. So we are happy to be here today with Spell's engineering manager, Ian, who joined Spell early on and has been heavily involved in building the core run and machine management infrastructure, support for Google Cloud project, the Jupyter product, the HyperSearch product, and most recently the model serving product. So he will now give you a much more detailed overview of the platform. And yeah, I'm excited about this. So please, Ian, feel free to share your screen now.
Hey, thanks for the introduction, Naomi. That was awesome. And great presentation, Brian. That was very cool to see as well. Can everyone hear me okay? Sweet. Okay, sounds good. Let's jump in. Yeah, so like Naomi said, I work at Spell, and we have an end-to-end platform for training your machine learning models and then getting them off and deployed and into production so that you can actually do something with them. So I'm going to kind of walk you through the process here today. And the first thing I just wanted to show you is kind of the basis of all of Spell. So what I have here is the Keras examples repo. I cloned it off of GitHub. You can see I've done nothing special with it. It's just exactly as Keras provides it. I think there's probably varied levels of knowledge here, so I'm going to kind of give a brief background. Keras is just a really easy way to set up a machine learning model and train it. And one of the classic machine learning challenges is called CFAR, where you have 10 categories of images. You have dogs and frogs, you have trucks and planes, and you want to be able to predict what the image is. So this is a classic challenge for training a machine learning model. So let's go ahead and do it right here, right now. So in this repo, I think here it is. And what this is going to do, so Keras just uses TensorFlow, and it's going to go through and try and train this model on my MacBook Pro right here. And you know, it's a decent computer, but as you'll see, it does not scale well to the kinds of machine learning challenges that we have today. It looks like it's going to take a little over 5 minutes per epoch here, and there's 100 epochs, so you can do the math. That's going to take a long time. So what we did was we wanted to make it feel like you were still executing stuff on your machine, but give you more powerful hardware. And so all we did was we created this command, spell run, and then you choose a machine type. I'm going to use a T4, which is a GPU from NVIDIA, and we're going to run the same command we just ran. And this is just going to take this run, it's going to stream it off to this machine in Amazon, in AWS, and it's going to stream the logs back to me. So it looks and feels like it's running locally, when in reality, it's actually running on this much more powerful machine. So as you can see now, these, actually this is loading the data, but as you can see, the epochs will take on the order of like 12 seconds instead of the 5 minutes we were seeing earlier. So much more efficient, and much of the reason we did this originally was because this is actually what the scale you need to go about training your machine learning models. We also found it's a really great way to kind of track and organize your progress as you work on projects. So I think that's one of the things I really wanted to highlight for this team. As you collaborate with other people and work together, one of the things that's really hard to do is share your results. A lot of people just have spreadsheets and they take notes in their spreadsheets and stuff. And as a more traditional software engineer, I'm much more used to things like GitHub, where there's a lot of history just baked into the product, and a lot of collaboration is enabled that way. So in the same sense right here, we have this web platform, and a couple cool things going on in here. First off, we stream automatically the metrics from Keras back, so you can see how effective your model is in real time. I didn't have to do anything to enable that. We'll save all the outputs from the run when this run is over. We'll save the trained model, and you get the logs right down in here. You also get these machine metrics, which help you see that your GPU is indeed in use. It looks like we're using almost all the memory on the GPU, although we're not actually using all of its capacity otherwise. So these kind of things help you optimize your training as you go. What's also really cool about this is that you can see what all of your everyone else in your team has been up to. So I can see here what other people on my team have been up to. And we have a lot of organizational tools around that. You can put labels on these runs as well as pin runs that are important to you to kind of keep track of them. And then go ahead and filter for the ones that are actually interesting to you by creator or label or the command they used or the repository they were running in. So this just makes it a lot easier to kind of keep track of what everyone's doing, share progress. Let's say you have teammates who kind of spin onto a project partway through the project. This is a really good way to kind of get them up to speed fast and let them see what has been done and what's going on. Runs are also this great underlying unit that we use for everything else in the product. In particular, our Jupyter Workspaces product is entirely backed by this. We also have these hyper searches here that just launch a bunch of different runs, and they intelligently choose parameters within the parameter space you give it, so that we can kind of see what the most effective parameters are. So this is exactly that same CFAR model I just trained for you. But one of the things I did is I went through and I said, okay, let's go ahead and see if we increase the size of this layer, or if we increase the rate of dropout on this layer, et cetera, what is the impact on the model in the end? And so you have those all graphed here. And one of the things we can do is we can come down to this table of runs here. So again, like I said, the runs are such a great unit for this. This is the same concept. I just click back into it and it's a run, right? But you can see that when we compare them in this view, this was the most effective run in this group. And one of the other things I really like is these facet charts down here. So these help you understand, as I varied an individual parameter, what happened to my accuracy. So as you can see, and probably expectedly, if you increase dropout, especially, I didn't train this for that many epochs because I was just testing these parameters out. A high dropout does really hurt the accuracy of the model. You don't want a super high dropout. Also, you can see that increasing the size of the one of the convolutional layers, kernel, actually really did help performance. These runs did better than these runs. But the same wasn't really true for increasing the size of the final dense layer in this model. So these are just interesting observations that can be made when you're working through kind of trying to get the best performance out of your model. And then one of the things I'm really excited about that we've recently launched is a model server product, because the truth is, right, this isn't very interesting. You've trained a model, but you can't do much with it, right? What you want to see is you want to actually see it in action. So that's where our model server comes in. So the first thing we do is we help you organize these models. So this is the CFAR model I trained. It was that exact same run, as you can see, from that hyper search, the best run from it. I went ahead and made a model out of that. That's right here. And this model I then have served up right here as a server. And what's great about this is that most people who can train a machine learning model can also write the Python code necessary to serve up this model. And in this case, I wanted to show you, it was pretty straightforward. The predictor, all it does, so these are the categories, like I mentioned earlier. This machine learning model says, ah, look, it's a plane. All it does is load the model in one line over here. And then for every time you hit it, we call this function. We grab the image out of it. It's base 64 encoded. So we decode it. We scale it to the proper input size for the model. And then we go ahead and call we go ahead and perform inference with the trained model on that image. And then we say, what category did it return? So it's pretty straightforward. And I want to show it to you in action. So for example, this is not part of the CFAR training data set that comes with Keras and that people typically use, but I just went to Googled cute dog and got a pretty cute one, I think. And now I want to see if this model can actually predict what it is. Sure enough, it gets a dog back. Oh, I should probably show you what the query was as well. Pretty straightforward. Yeah, all it did was take that image that we just did, and it did a request to this address right here, which is the address of my server right here. So that's all it is. But it's a really powerful option because most people don't have a lot of setting up a Kubernetes cluster, and all the DevOps stuff behind that is a lot of work. So we take that part of the work away from you. And I wanted to show, this is the kind of the example we've been using to show how powerful this can be. one of the people on my team made this JavaScript app. And all it does is it lets you take these different elements and color this in. And then it uses a pre-trained GAN to say, okay, let me try and apply Bob Ross's painting styles to this thing that you've just made here. So we run this. And so now it's hitting the model server in the background, the one that we deployed, and this is your painting. So fun tool, anyone can play with it, just paintwith.spell.ml. And I think it really highlights the powerfulness of this model serving product. So that's exciting. Yeah, and I wanted to highlight as well one of the really interesting projects that we've been doing with YCombinator over the years. We've had a number of partnerships. One that I thought was really cool in particular is there's unfortunately much more than I realized, illegal dumping of waste, toxins, etc., into rivers and oceans in different places, different natural habitats. And unfortunately, in many countries, it's hard to police this. So it turns out we can actually use images to predict where this is occurring. We can train models to figure out where this is occurring. So this is a project that YCombinator and Spell partnered on, and I thought was really interesting. And if you Google it, there are a bunch of great articles that YCombinator wrote up on it. So check those out. And that's all I have for you today.
Thank you. It was pretty cool to learn about all this. Thank you so much, Ian, for sharing your knowledge with us. Now we will be jumping to our third panelist. It's time for Activeloop. So managing data sets can be a hassle. So especially on a large scale. Collaborating around unstructured data, as well as storing, accessing, and version controlling it is very hard. Having battled this during his time at Princeton Neuroscience Lab, Activeloop CEO David Bunyatan has resolved this issue. David and his team have built an open source package that resolves the biggest pains of dataset management. So today, David will walk you through how Activeloop's tools have helped YCombinatore's contributors follow the best practices of building scalable data pipelines and managing data sets for deep learning tasks. So David, now it's your turn, and yeah.
Thanks, Naomi, for this extensive introduction. Actually, I just finished the presentation after this, so there's not much else to say. Anyway, glad to be here. Brian, Jan, your presentations were very cool. Glad to see you here. And let me get started, basically. So when I was data scientist and machine learning engineer, or doing my PhD, while dealing with petabyte scale data, like I had the expectation that, hey, I'm going to Princeton, I'm going to do like machine learning, deep learning, and as far as I see, like all the data scientists have this expectation that they should be like AI heroes. They should run a lot of experiments. They should try to do a lot of different architectures. But the true reality is that we spend a lot of time on data preparation, data management, like how to store the data, where to store it, and so on. So if you look into all this, like the pipeline, as you saw with Brian's case and like the Labelbox case, where they focus mostly on annotation side, and they have like Spell where they focus on the training side, where we are focusing mostly is like this gap between where you have the annotations and then you have to go to the training process. So we also saw like companies we work with, they spend in average like 1 month to just take a model and put it into production. And the same happens with like data scientists spend half of their time on the data preparation step. As well, if you look into the data that generated today, is like 90% is unstructured data. And why we are talking about this 90%, because there's the other 10% where you have companies like Databricks, Snowflake, or like data warehouses, data lakes, and so on that focus on solving this 10%. But you have this uncharted territory where things left are like not solved yet, and we are all like here kind of trying to give industry standard. So what I've seen, like basically managing really large data, when those are the main problems where you have to deal with. So one of them is that when you're writing a code, it's like you have to make it dependent on the data set and how the file structure is set up or how the labels are annotated and so on. Then you actually had to spend time and write this preparation step going from the raw data itself to the training process. If you're working with a team, and I think like both other solutions are very great here, is that it's like you have to synchronize with other team members and make sure you're on the same part. Of course, like if you're working or you're really dealing with large data, you have to also want to like access a small part of it, any part of it, and then visualize it. As well, like sometimes there's an issue with the managing resources as well, and a single machine, just like managing this, putting into a single machine is impossible. And like even if you have terabytes of data, that's also like not possible. So you have to deal with this, like kind of making sure that you have this streamline from the cold storage to the RAM itself, and you have the caching in between to have the efficiency of data. And one of the most important things here that's kind of missed is that when you're trying to train a model, you want to make sure that the computation itself is very local to the data itself, or the data is local to the compute. And that's what we are all about here. Like, as you see with the example of CFAR, let's say, or like MNIST we saw, like you have to write this 40 lines of code in order to go from the raw data itself to the training process. Like this is not the training code, this is just reading the data and then starting. And the MNIST and or CFAR is a very basic example. Like it's the most trivial thing you can do. And you still have to write all this code to be able to read it. And what we offer to the data scientist is that you can actually take a step and then in 2 lines load the data set and then transform into TensorFlow or PyTorch and directly start training the model. And one of the essential benefits here, what we are dealing with, is that we can go like from the raw data itself, like stream this to the machine that you're working with, either local on the machine or it's on the cloud. It could be run at scale, it could be run on a single machine and so on. And you do the streamlining, you start doing the training process, and we bring the data to you. So what we have seen also working with the Omdina case is that the data scientists, they have to spend like 14 plus hours to go from this raw data, downloading satellite imagery, and then loading and doing all this pre-processing step. Instead, if they do it once, basically, they can just access this data in a matter of seconds. And here's an example. We also like provide a visualization tool that you are able to visualize the data. And data scientists basically can both upload the data set as you like work with, let's say with Docker, so you can consider each data set as a single Docker, you can access it anywhere and then stream and start doing the training process. But one of the things that would be realized is that visualization step is actually very important. And the same thing happened at my lab as well previously. So where we had to deal with large amount of data, I mean, you have to have good tools to be able to visualize this data and like find the areas where the models are wrong or how the predictions are done and so on. So we're also like very glad to just recently get started working with Omdina. And one of the first projects that we are working with is the like basically predicting the poverty levels using satellite imagery. And that's one of the problems that we have been working with the team. And like this is kind of the first step for us as well. And we're getting the feedback loop from the data science community, how we can improve the product. And it's very been helpful for us in that sense. But also like what we are trying to be here is that try to give back to the community as much as we can. And here's the first task example with a team, and you can see the results basically. And this is kind of the second example where we are trying to kind of find a correlation between district AOI and the images at the satellite imagery working with. So as you can see, the results basically help to improve the speed and the efficiency working as a team. And one of the nicest things that what they have to do is like the data scientists, they don't have to go away from their internal tools, what they're using. Like they have been bottlenecked on using Google Colab and actually downloading this big data. When I hear say big, it's not actually that big. It's like a couple gigabytes of data, but it's still very difficult to run it on a Google Colab tool. So we help them actually streamline this process to their data scientists. And what we focus mostly on here is the kind of trying to unify the data set storage and provide an industry standard, how to store the data and how actually focus on unstructured data sets. And when we are mostly helpful here is that we take kind of your unstructured data, repackage into our unified format, and then you can And then you can store it either on your cloud, you can store it on our hosted services, and you can stream this to PyTorch or TensorFlow directly. And we help you to deploy like basically models and stream the data back into the pipeline, and you have this active learning process as well. That's what we are like called Activeloop. Thank you very much, and glad to be here. Also, like if you have time, basically feel free to go and start our GitHub package, and happy to answer any question if you have.
Thank you. Thank you so much for this great presentation. We will now be jumping to some questions. We don't have that much time because we've had amazing conversations right now. But first question, I'll take it from the audience to make sure I leave time to answer questions from the audience. The question is for Brian. So labeling is often a massive job. So what do you see as the ideal way to approach that process to ensure the relevant domain knowledge is always being considered?
Yeah, that's a great question. The magic of machine learning is that as we see all these tools and technologies emerge, like we did in software, we'll be able to have the domain experts of the world scale their intelligence and their capabilities, unlike they were with software. They don't have to necessarily learn how to write code. And so that's very exciting, but how do we kind of solve that domain knowledge problem itself? I think it's the right question to ask. What we've found is that getting the domain right, having the deep domain expertise needed to solve a problem in an environment or in a domain of application is super important. And all of that hinges on essentially what you would consider the ontology, which is the structure of the data that you're labeling and then using to teach your machine learning system ultimately. And that ontology iterates over time. So you're going to change your ontology as you learn things about the model performance, and you're going to change your ontology when you learn things about labeling operations. You're going to learn that it's easier to label some classes in some ways and harder in other ways. And that's a kind of a fine balance between how you label and the operation of labeling and the quality that you're getting, and what the data science team, data engineer, machine learning engineer teams need to make the model as performant as possible where it's operating. So that's kind of two roles, right? You have this data science role that's looking kind of ontology data forward into the model, and then you have this kind of labeling and operational role around how are we going to understand our business problem and how are we going to actually label this data accurately and consistently over a long period of time. Because ultimately this model will run in production, and it's important that you have the system set up. So it's a really fine balance, and ultimately iteration is the secret, but it's important to get right. The best companies we work with spend a lot of time making sure their domain ties tightly to their ontology and continues to iterate.
Thank you. Thank you so much for this. So my second question would be for David. What are the biggest challenges that you see in helping companies implement implement AI solutions? Where do you see where they need the most support to launch these initiatives?
Yeah, so one of the things that we see, and I think all the other companies also see, is that most of the project gets stalled. And one of the reasons is that, first of all, like many companies, they are clearly not yet sure how they're going to use AI. So I don't think that's a good use case for using AI for the sake of AI. And the other part that they already defined the problem and it's clear what they want to achieve, here's just a methodology they had to follow. And it's very similar to how to build the startup. Basically, you have to get the MVP version out to the production as soon as possible, and then get into this feedback loop, try to iterate. I think going through this step, and if you are doing the first time, is a challenging, because there are so many unknowns that you have to kind of define on the paper. And I think like this kind of steps, like collecting the data correctly, like making sure it's clean, it's annotated, and then you have to take the preparation step correctly, and then go through the training and deploying a model. So you can like iterate this in a very fast forward, like a lot of data scientists, they think it can do this in a week or two, but like the 80% of the work is actually done on this last 20% accuracy improvement over the model and the production part. And one of the reasons is that you have to carefully think all the ways, like how the model could be affected by different types of data, and like how to make sure that deploying the model itself is very safe.
Thank you. Thank you for elaborating on this. This question is for Ian. So your spell, so your technology has helped our collaborators. So Andena collaborators with also many other organizations around the world. So when you work on such projects, especially with the Andena collaborators, has this close contact and this collaboration helped you also build new models or improve your technology on your end and develop solutions that you thought at first you didn't need to develop?
Yeah, absolutely. We're always learning from our users. I think it's one of the most interesting parts of this process. I think that this industry is still it's still young. There's so much potential right now, but we don't know exactly what direction it's all going to go. So it's pretty key to listen to the users as they use things and see what people do in practice. I mean, the big challenges that we kind of see for people as broad terms are collaboration and iteration. I think themes that have been iterated a lot here today. And what that really means in practice can vary a lot. So for example, this recent serving product we came out with was heavily influenced by going back and talking to a bunch of our existing users. We had tried a more narrow serving approach at first and it didn't work out for people. But we figured out what they actually needed based on the actual use they were doing of training their models on Spell. So yeah.
Thank you. I will take now another question from the audience. Wait, I just scrolled past it. Sorry. This question is for everyone. So any one of you can jump in if needed. But what tools do you think that the AI for Good community is needing? Do you think there's something that's missing that you would like to add in, or yeah, what tools are missing, especially for the AI for Good community?
I guess I can jump in with one thing. I think that it's really important to be able to reproduce your results, and particularly for communities like AI for Good, where you're spread around the globe and you're working with a lot of emerging technologies. I mean, the stats on the number of white papers that are not reproducible in practice is pretty staggering. So I think and anything that we can do to kind of fully document and make it entirely possible for anyone else to come back to the same results is pretty key to continuing to kind of grow the AI for Good solutions out there.
Thank you. No one else wants to jump in? Oh, it's okay. Maybe one last question. That is also a question from the audience. Wait. At what stage an AI startup should be to be able to use your tools effectively? This question is for anyone who would like to answer. Yeah, so at what stage should an AI startup be?
In our case, since like core open source, we can start from scratch. Like when you're starting the company, you can start using the open source product. And then once you start scaling like to really large scale data, you can get ahead and then move into more kind of subscription-based model.
Okay. Well, I think maybe the last question before we have to wrap it up. What do you see happening or being adopted in terms of AI by enterprises, big or small, in the near future? So where do you see this industry as a whole going? How do you aim keeping up with the rapid change? How do you see it all going? Again, it's a question for anyone who would like to answer.
I can talk about that. We work with a lot of enterprises. You know, one of the interesting things that I discovered along this journey is that Facebook has an entire department or team essentially that manages their ontology. And that's really interesting. Facebook is pretty advanced in some of their computer vision and their machine learning efforts. Their organizational structure is very advanced as well compared to other organizations. And I think those point to what the future is going to look like for many enterprises. There's going to be a transformation in the way that companies organize themselves around machine learning work, the way that we organize ourselves around software. We organize around agile and pods, and we've kind of figured this out over the last 60 years. That is going to change to some extent with machine learning. We're going to continue building software. We're also going to start building machine learning. So we're going to have different organizational structures. So companies are going to have to go through those transformations. Are we going to do sprints? Are we going to do something slightly different? How are we going to organize ourselves and our expertises together to get things done? And then also around data provenance and management, right? So Facebook's ontology management group really oversees all their model capabilities, meaning if you have a team over here doing facial recognition and a team over here doing content moderation, when they're calling a face, they want both faces to mean the same thing at some sense. So they have some sort of traceability and model and some more centralized understanding as a company of what their machine learning capabilities are, where they're strong and where they're weak. And you see that today in software where you have sort of centralized IT and DevOps around like what is the sort of application stack and where in the stack are things breaking, and at some level you have an understanding of the company's sort of software landscape and surface area and how things play on each other and work together and are managed together. So I think we'll see all of those things happen in machine learning. They'll look different. There'll be new companies. There'll be trillions and trillions of dollars of market for these companies to take across the whole stack. So I think it'll be very, very exciting.
Thank you so much, all of you. I think now it will be time to wrap up. It's almost been an hour. Thank you so much. If you have any additional questions from the audience, I'm talking to the audience. If you have any additional questions, please feel free to email me at noemi@omdena.com or any of these three panelists. Always happy to share more information. The recording will be available on omdena.com on our blog, along with all of our other demo days. So please do not hesitate to get in touch with us or with our panelists, and always happy to start a new conversation. So thank you so much, everyone. It was great chatting with you, and talk to you soon. And yeah, thank you.
Thank you.